Good evening, everyone, and welcome to this wonderful session. And I think, as we have always taken our good pride, that this is a particular, sector which is personally, honestly speaking, is very, very close to my heart. For the very simple reason that I always have this feeling in my mind that, for some reason or the other, in fact, for some strange reasons, unfortunately, this sector has not got its due. And I really, sometimes I keep talking to Mr. Gaurav Ketia that what could have been the reasons behind this, when India on one hand is actually gaining a huge milestones, month after month, year after year, when it comes to renewable energy, the kind of targets where we were a few years back, where we are today, and what we have envisioned ourselves until the year 2030. I think there's a huge thrust on solar, there's a huge thrust on wind, but somehow this sector of biogas, the bioenergy, that has not met its the kind of what it actually deserves. So for me, probably that's one of the reasons that I really empathize with the sector, that has tremendous potential for a country like India, which has enough of feedstock, and we have such a large population which can be powered by this, biogas. But for some reason, we really need to deliberate on it. And probably this is one sector where we have not left untouched in many of our successful editions from the past. That we need to continue talking about this sector. What is that stimulating a technology in this particular sector? What is that required in terms of policy framework, which is a must to bring the overall development and sustainability of biogas in India? Because then only it can help the decarbonization and provide the foundation of a circular and the waste to energy based economy to ensure a greener future for the country. And welcome everyone. Welcome Mr. Srinivas. Srinivas has been working with us for quite some time in our multiple shows, and he'll be the one who'll be moderating our today's session. And then I very warmly welcome three of our international panelists. We have Mr. Florian Wade. He's a sales director with Armatech FTS. Mr. Han Rep, managing director and founder of Biogas Academy. And of course, Mr. Gunther Stocker is the managing director of ETA Gas. And over to you, Srinivas. And I'm really wish everyone, all the attendees, all the participants, of course, the speakers, good luck and best wishes for this session of the day. Thank you very much. And over to you, Srinivas.
Yeah, thank you, Rajnishji, and thank you for the lovely introduction. And yes, I would like to welcome all the speakers once again. And as we are going to start our session for potential of biogas between dream and reality. So when, if anyone asks about the potential, then yes, India is likely to see worth almost rupees 2 trillion INR to set up 5,000 CBG plants in India across the country. And despite the numerous potential benefits of organic waste or utilization, including environmental protection, investment, and job creation, India currently has only few large-scale plants. If you talk in terms of percentage, yes, it is less than 1% of the total overall estimated figures. So just one can understand about the potential this field has. Okay, so we are talking about huge and large potential. And yes, as I said, the change is happening. And India is strengthening the link between the renewable energy and the agriculture. So this is a lovely statement which I always like, and I would like to repeat that India is strengthening the link between renewable energy and agriculture. And this is essential to create a healthier and a cleaner environment and develop a more resilient, efficient, and sustainable farming sector. So this will not only enable entrepreneurs to diversify their activities by producing biofertilizers and bioenergy, but yes, this would be overall development when we work towards reducing the crude import or fossil fuels. And yes, the share of biogas energy in India has started increasing and will increase multifold in the coming 2 to 3 years. So when we're talking about biogas technologies are now among the technologies that offer cost-effective, scalable renewable energy alongside wind and solar power. As Rajnishji has already said that, and he has been motivating us since years, and he is also personally favoring this technology, which we have been passionate and working night and day in. And this development has enormous potential to change India's energy systems by turning the waste to green power. So let's see what we have to cover in this session. And we love first like to welcome our first speaker, Dr. Jan Rapp, and he's a surgeon and senior medical consultant in Stockholm, Sweden since 2007. And one of his friend has told him about 250 Stockholm buses which are fueled by biomethane or bio-CNG, a non-fossil fuel with a minimum emissions, produced locally in Stockholm from sewage and food waste. And his reaction was, could this possibly correct? And yes, as as Dr. Jan Rapp is passionate about biogas energy, and we connect from various angles. And yes, and with the aim of a fast worldwide implementation of biogas technology, his non-profit organization Biogas Academy is creating communication concepts, increasing knowledge of biogas value chain. And today, the Biogas Academy collaborate with companies, but also municipalities, corporations, or wherever the large waste generators are there. And they represent organizations also like European Biogas Association. So let us hear from Dr. Jan Rapp. Yes, Dr. Jan Rapp.
Thank you so much. Thank you for a lovely introduction and for having me on this panel. Exactly as you said, I'm sure that everyone listening today have heard of, are familiar with biogas for a much longer period than me. But you could say that I've been environmentally conscious all my life. And I was completely baffled when I heard about this technology. But the second thought that came to me was that no one knows about this. I live in one of the cities where we collect a lot of solid municipal waste. We collect household waste. We make biogas for buses from all the sewage in Stockholm, but I never heard of it. And it was quite obvious to me that a technology which is not known, not by me, not by policymakers, will be very, very sensitive to other marketing attempts. If you market other ways of producing energy, other ways of powering cars, etc., the unknown technology is becomes sensitive. So I started to think, how can we do something about this? How can we act in a way to make as many decision makers and policymakers, but also, so to speak, the man in the street, more conscious about this technology. So every mayor, every energy business CEO will feel this is something we want in our portfolio. So this is the first question I would like to pose. And this is, of course, my assumption is that there are advantages at every level. There are advantages for the whole household that know that they can produce gas for their kitchen if they put their organic waste in a small digester. But there's also a great advantage for the municipality or the company that invests in a digester because you get ultra low carbon emission energy. And as you very well know, and are an expert in, Srinivas, the biofertilizer. And so my assumption that this is something worthwhile fighting for is that this is a true game changer in both waste treatment and energy production. And just like today, everyone is very well aware of that solar power, wind power, hydroelectric power are basis of sustainable energy. This is the same. This is also a pillar of intelligent waste handling and energy production. And if all policymakers and investors feel confident with this, they won't hesitate when it comes neither to investment or policies. And how do we make people more confident? Well, we teach them, and we teach them through communication. And this is where this thought came up to me. If you look around yourself in Sweden, in the municipal side, all the garbage cans, the organic waste bins, have different markings. Most of them don't even say that it's something that goes to biogas. When you look at cars in Sweden running on biomethane, it's impossible to see it. So both the public side and the commercial side, they don't have a common way of saying, yes, we are a company, but we are in the magic biogas circle. So that's the idea that came up. Why not make a logo? Every successful global product has a logo. So why doesn't biogas have a logo? So we had a project with 15 Swedish companies, and they all said, this is a great idea. And during 4 months workshops, we developed and came up with this suggestion for a logo. And now this is spreading in Sweden. And of course, one advantage, us being Biogas Academy, being a non-profit organization, is that a public bus operator, for example, can use this logo, but a private energy company can also use it. And the private energy company marketing biogas could never get their own logo on the municipal buses or the waste collection, the public waste collection. But by having a non-profit independent logo, we can introduce this concept in both public markets and private sector. Another thing that was obvious is that there are almost unlimited surfaces where this can be used. The surfaces of the production are the digesters, as you already seen, the trucks transporting digestate, tanks, of course, they're huge surfaces. And also fueling stations, the same. There are, I think, 4 fueling stations in Sweden that look like this. They are not even marketing their own brand, but they are completely focusing on the biogas logo. But if you think further, you end up that almost any situation where you handle some kind of food, you can connect to biogas, which gives an almost, as I said, unlimited number of exposing this logo, which are free. So these are examples from Stockholm, where a yellow taxi cab company, they have their own brand, but they still on the lid or the tab for the fueling on the car, they use the logo, which then is matched with their color, design colors. The truck in the center is from Arlanda. They also have their own Scandinavian service partner logos, but they add the biogas logo. And the other is a recycling firm driving their trucks on compressed biomethane. And they also, along with their own logo, they introduce the biomethane, the biogas logo. And this is an illustration just to show that there is great interest in communicating that you are sustainable. This is an Italian grocery chain called Lidl, and the whole truck is about biomethane. So there is no discussion that this is becoming something you want to communicate as a company. And we argue that if we just could introduce a little cooperation between all the different stakeholders by using a unifying logo, the power of this communication would be much stronger. It gives also a versatility, because by keeping this outer shape, we can alter the languages. The one to the far right is in Finnish language. The ones in the center are, of course, the biomethane or the bio-CNG. So there's no contradiction between that. There's no confrontation. We can have this unifying B, and then we can change according to the language or whatever mix we're talking about, or colors, of course. Another thing that is advantageous when you have a logo is that it's much easier if you want to pay for ads, or if you want to buy commercial surfaces to activate them for your purposes. Then it's also much easier. It's easy to join different commercial stakeholders in one project if all agree to that. Okay, we are behind this campaign. If you read the website or the campaign, ads in papers, the company logo is there, but the main thing featured is the common thing, namely the biogas, which also then enhances the value of this. Another communicational concept that we developed was Biogas Week. We discovered that if you discuss different marketing campaigns with different stakeholders, it's always like everyone has their own calendar. So by saying that second week of May, for example, is Biogas Week, then just by clarifying that there's a short period of time, it's 1 week, then the car sales people, the municipal people that want to inform about organic waste recycling, and all the grocery stores wanting to tell the public and customers that they are in fact sorting their organic food waste to biogas, they can join in that week. And of course, when you join, as you see, if you see in the center picture in the low, there's a newspaper ad, a magazine ad, and there at the bottom of the ad, you can see that there are 12 different companies, Volkswagen, Audi, taxi, producers, so forth. And they're all joining behind the campaign. So of course, the effect of the campaign is much larger when you unify behind a common message. This is another communicational concept. In order to link biogas to strong brands in Sweden, we work with large companies and we help them introduce organic or recycling at their offices. And then of course, when it comes to the organic fraction, we introduce the biogas logo. So on everything that has to do with describing why are you sorting your banana peel in this office, we introduce the biogas logo, which then makes the biogas logo part of this brand. And that is what we want. A third one is the corporate image externally communicated. This is the website from the Nobel Prize dinner restaurant in Stockholm. And on their website, they say that we are part of the biogas value chain. We sort our food waste from the Nobel Prize dinner, and we cook on biomethane or biogas from that residue. So then suddenly we become part of the Nobel Prize brand, which of course benefits biogas and the feeling that the public and the policymakers have about biogas. Oh, it's Nobel Prize dinner level. Okay, that's clever. That's clever. So that we should use. And let's see now if I can change to the next one. Yes, this is another example of this. Restaurants that we tell about this, how clever it is that they're sorting. They become so proud that they start telling the customers. So on each table in this restaurant, there's a small table talker saying, this restaurant does something very good for Sweden. And on the other side, the biogas logo. And then the people, when you inform them about what they are doing and how good it is for their city, they start to feel proud about that. And then you can sell them a certificate. And now they are posing in front of their restaurants or coffee grinders or whatever with that diploma. And of course, all of this makes these products something that obviously connects to happy people like Coca-Cola or Benetton or whoever, who is always working with image and the social feeling connected to this product. So here we have happy people from different parts of the world serving different food, but they're always all of them are happy. Why? Because they are in the biogas chain. So this is very easy. And the last picture is from Arlanda Airport, where we suggested that the 400 toilets there, which sewage goes to a biogas production plant, they put this golden sticker on all the toilets saying this is a biogas production facility, and then we make fun of us Swedes saying that we take shit from everybody, and then on the second line we say it runs our buses. So and I mean, most decision makers and policymakers do eventually have to go to the toilet. So this product that we have, it's not only a game changer and like a Swiss Army knife of sustainability. The different possibilities of communicating this are equally vast, because it's everywhere in our society. And then we just have to reach those spaces, and we suggest that this is something we can do cleverly by doing some of this in a coordinated way. Thank you.
Yeah, thank you, Dr. Jan. And I personally loved the logo which showcased, it was Biogas Kasula or Bio Kasula. So it attracted me in the Finnish language. And yes, and I would like to introduce our next speaker, Mr. Florian Wook. He is an sales director of Armatech FTS and environmental engineer by profession. He has around more than a decade of rich experience in anaerobic digesters and other segments when you talk about biogas plant. He has marked and recommended many products for the worldwide plants based on the actual requirements of, let's say you name it, the biogas agitators, solid liquid separators, pumps, etc. So let's see what we have to hear from Dr. Florian Wook. Yes, doctor.
Thank you very much. Thank you for introducing, and I will share my desktop for you now. Wait a second. Yes. My name is Florian Wook. I'm the sales director for Armatech FTS, a German brand company. We produce components for the whole biogas plants, wastewater treatment, agriculture, and industry. And we will make in the future, I think in September, we will make a subsidiary in India, this Armatech India Limited company, with our sales manager, Mr. Vijay Kumar. Yeah, and I think it's a really good market, the Indian market, but I think you need more information, or the most people need more information about components for biogas plants, because we in Germany or in Europe, we have many experience in the biogas plants. In Germany, we have 9,000 biogas plants. I think so much biogas plants you haven't in India, only small one, yes, I know, but the bigger one are less. But I think in the next time you will make many biogas plants, and we have, I think now 40 or 50 mixers sold to India in the last year, and we hope we grow up in Indian market. Okay, let me introduce the company, Armatech FTS, producer for components for biogas plants. We are around we have projects around the world. Here you see a 2 megawatt biogas plant in Thailand. We sold our mixers, pumps, and submersible mixers on 2015. Next one is in Thailand too. It's a pilot project from the University of Khon Kaen. It's only a small project, but with steel tanks. You see, in Indian market, you have many steel tanks, and it's not a problem for us to install our mixers or submersible mixers inside these tanks. Our biggest project is now on the Philippines. We sell our products, long shaft mixers, dosing system with liquid feeding, cavity pumps, and centrifugal pumps on 2019. You see every time steel tanks in Asian market. We have the first project we sell to India was the IoT Biogas biogas plant in Namakkal. I think now more than 10 years, the mixers work really well without any problems. And we haven't so much warranty, only the propeller you must change after 4 or 5 years. The inputs are chicken manure, cow manure, and sago water. I think the substrate are not really easy, but our mixers can work with them. It's not a problem. Yeah, and we have projects in South America, in Chile with municipal waste, or in Brazil with municipal waste. Last year we made a bigger project in Dubai with all our components, from the dosing system till the separating system, with pumps, mixers, everything. Yeah. Here I will show you our products we can sell to Indian market, and we produce in our house. the mixers are for concrete, steel, and animal tanks and lagoons too. Long shaft agitators, paddle mixers, submersible mixers. Here you can see our long shaft agitators, our ultra mixer. You can install it 8 meters under filling level. Then you see the compact mixer. It's in Europe the energy efficiency long axis mixers. Then the compact, you can install it in the sidewall or in the roof when you have a concrete roof. But I think in Indian market you have the most time a membrane cover on the tanks. And our twin mixer, one of the longest long shaft mixer with 2 propeller on 1 shaft. I think it's the only long shaft mixer you can install 2 or 3 propeller on it without any support inside the tank. Yeah, here you can see the direction you can change the mixers. Yeah, these are small pictures from the mixers in Germany or around the world. You see the Armamix Twin with a 2 propeller on it. You can install a third one when you will mix every level inside the tank. Here's the compact mixer. Compact mixer is now really the efficiency mixer on the European market with a polyamide 3D propeller. We can work with this agitator with 7.5 kilowatt. Normally in a digester with approximately 10-12% dry matter content, you have current from around about 10 ampere. Here you can see the ultra mixer. This one you can install up to 8 meter under filling level with a polyamide propeller on for steel tank with a console and a mixing tower. This is our paddle agitator for mixing pits or something. When you have really high dry matter content, when you have long fibers and everything, you can install this unit. This is our new mixer. It's really new on the market now. This is our Armamix Hybrid. It's a long shaft mixer with a submersible mixer in front of it. We know in German market the submersible mixer are really good for end storage tanks and something, but nobody will change the level with a submersible mixer. I think 5 or 10% make it, but the most people didn't do that. And for this, we have the Armamix Hybrid now. You can use a hydraulic pump or with electric connection. You can install it under the filling level and can change the direction with the filling level. It's really new now. We install now two pieces in Germany. I think it's normally not a problem because a submersible mixer know everybody, and the other one is a long shaft mixer. You haven't any problems with that. Yeah, submersible mixer with a polyamide propeller with a power consumption from 4 kilowatt up to 15 kilowatt. Small submersible mixer with high speed 380 RPMs. Yeah, and then we produce pumps in Germany too. We have our big progressive cavity pumps, our feeding pumps for liquid feeding systems, blower pumps. It's a really interesting pump. We are only a company, they produce this pump. It's with a tire under the pump, and it's for substrate when you have really mud, glass or stones inside. The pump have not so much power, only 20 cubic meters per hour, but the most time we use it in dairy farms or something for a channel mixing system. We put this one inside and then you can pump it directly to the digester. And the normal centrifugal pumps for pre-tanks or to filling any tankers or something. Here, the progressive cavity pumps, we have small one, the NF pumps and the end pumps. The end pumps have a special drive unit for a really easy service. And we sell our normal pumps every time with retentionable status for longer lifetime. Here you can see our NF80 pumps around the world, here in Thailand, Switzerland, Germany. This is the bigger one. Yeah, then we have progressive cavity pumps submerged. It's a vertical pump up to 5.5 meter long. And here you can see it's a bigger one with up to 9.2 kilowatt for open and closed tanks, flow rates up to 50 cubic meter, the pressure up to 12 bar. It's really interesting for feeding the separating system. And you have a small propeller at the bottom from the pump. There you can mix a little bit the substrate before you pump it. Here you can see the feeding pumps, liquid feeding pumps. I think these units are really good for when you have 1 or 2 biogas lines, then you need only one dosing system and one liquid feeding, and you can pump the substrate in every tank from your biogas plant. When you have many stones or something inside, or long fibers of grass or something, then it's a really perfect solution, because you mix it before you pump it in your digester or in your hydrolysis tank or something. And yeah, then you have need so much mixing time in your tanks when you have a homogenized substrate directly from the liquid feeding pump. Yeah, this is the biggest liquid feeding pump we have, up to 85 cubic meters with a hopper 3 meter long. Then we can install it directly under the dosing system. Yeah, here you can see our blower pump I introduced for less minutes. Yeah, this is for sewage treatments, for municipal waste. When you have stones, glass, or something inside, you have a small service opening. You can clean it, and it's like this pump is like a heart. You have flaps inside, and will suck it and pump it to the digester or next tank. You can see it in wastewater treatment plants. Here, submersed this pump, you can install it directly in a chamber or something. Here you can see our centrifugal pumps up to 5.5 meter height, up to 7.2 cubic meters per hour, per minute. When you need to fill a tanker or something, when you need much power, a high flow rate or something, then is this the perfect pump. For biogas plants in pre-tanks or something, for separators or something, is not the best one, because you can't control this pump really good with frequency converter or something. Then you need a cavity pump. Yeah, normal centrifugal pump for biogas plants, not submerged. When you will pump from one tank to the next tank, you can use this pump. And here you can see our separating system. It's a mobile system, or you can install it directly at the biogas plant. Normally they separate 6 to 20 cubic meters with a dry matter content up to 35%. Only with 3 kilowatt or 5.5 kilowatt. It's a really small one, but a really good one with a really long lifetime. When you need more, you can use 2 or 3 pieces. Then you have not so much problems when any problem is one separating system. Yeah. And here we have a small pipe inline cutter for homogenizing the substrate before you pump it through the cavity pump. You have a little bit more a longer lifetime with this unit for the cavity pump. You can cut fibers or small wooden sticks or something. It's really interesting, but it's not a big cutter. It's only a small one. Yeah, and we have our dosing systems, solid doser, to put it over our liquid feeding pump up to 300 cubic meters, many different units we have with this drums or with any other parts. Okay, thank you very much. This was the components for biogas plants from the company Armatech. If you have any.
Thank you, Florian. And yes, there would be there are many questions, and we'll be take into the next session. And as we are, since you have already come to India, and I'm sure that you'll be love working with the Indians. And our next speaker for the session would be agronomist Gunther Stocker, and he's born and brought up in Vipiano, northern part of Italy, and he has a degree in agricultural science, where in animal nutrition. And when everybody talks about the black box, or digester is just a black box, but Gunther is a person who has come across many enzymes, micronutrients, and he showcases that this is not just a black box, but there is a science behind it and how we can enhance the process. So continuing given reliability of the biogas process, and dimensioning to various processes to this project or the biogas project, Gunther is a process designer and choose different technological parts like feeding systems, mixers or enzymes. And he has taken this in the career as an anaerobic digestion expert. And he's a CEO of Itagas, and he's on the mission of bringing excellence in anaerobic digestion and working in Europe, North and South America. Now started working in Asia. And let's hear what Gunther has to talk about enzymes and micronutrients to be added in the digester. And we'll take the questions once the presentation is complete by Gunther.
Hello to everyone. Can you see now my screen?
No, screen is not visible, but you are audible.
Okay, hello again to everyone. My name is Gunther Stocker. Thank you for the introduction. Thank you for the possibility to share my thoughts about process design and the interaction with trace elements and enzymes. So first, a quick presentation of myself. Just like Srinivas mentioned, I have a degree in animal nutrition, and then since 2006, I worked in anaerobic digestion in different roles, in different positions, in different companies, with also different focus on technical issues, process, even technical aspects from sales. And since 2007, I had also the focus on the micronutrients. Nowadays, I not only focus anymore on anaerobic digestion, also speaking about renewable energy. The conclusion is very similar. So from biogas, I can produce green hydrogen. From biogas, I can build up renewable fuels. Green hydrogen, I can do also the production from plasma gasification. So I had a little bit wider approach to renewable energies. Process design. Let's talk a little bit about the process design. What are the targets? They're simple targets. Let's keep simple the question. Let's keep simple the anaerobic digestion. What we have to do for the most important thing is to respect the needs of the microorganism. This is very important. Then we have every time focus on the efficiency. Once we start with the project in emerging market, in emerging country, let's do something really flexible and especially long-lasting projects. Yeah, I have written it down easily. We have to avoid common mistakes and frequent problems. If you look to LinkedIn, how many pictures we can see every week from biogas plants cleaned out. So deposits, floating layers, we already heard that we can do a lot with the different type of mixers. And of course, also foam. Everything, especially for the mixing system and pumping system, is very often directly or indirectly linked to the dry material. So we have to focus very well. The higher levels, 10-12%, we have to go up a little bit. So not every time common and normally CSTR technology is the best choice. We have to go over this. Process design, my degree with animal nutrition gave me very close look to the ruminants, and I think we have to get our inspiration from Mother Nature. Mother Nature has given us already one of the best available technology. For the ruminants, they have 4 stomachs. They have also the possibility to ingest food, and then in a second time doing the chewing. Of course, during the pumping, I need sometimes some first treatment, but I'm talking about really deep mechanical treatment. From the rumen, only small size particle can leave and go to the next stop. So saying it in one sentence, hydraulic retention time must be different from solid retention time. So the solids need a long time to get digested, nearly complete. So this is the main issue. Rumination is a combination between biological, chemical, enzymatic, and mechanical treatment. In the anaerobic digestion with an acid pH, enzyme addition, and mechanical treatment, we can guarantee to digest fibrous material. Like the cow, even here on the anaerobic digestion, we need add macro and micronutrients to make sure that we have success. So the process design can be really inspired by ruminants. Ruminants, in this case, in the anaerobic digestion, we are going towards a plug flow technology. Not every time, not saying that every time it's useful to go to a common plug flow technology. We can combine this together with wet technology and of course plug flow together, like the cow, like from the rumen. We can have with separation. Armatech has chosen different solution, so we can leave the first stage of digestion to the bacteria and go then after the separation directly in an even anaerobic thermophile plug flow digester. Mechanical treatment has to be focused on the fibrous part. It's not helpful to deal with a lot of water, with a lot of easy digestible input material like corn silage. We have to focus on the fiber. To separate from time to time, we can we have the experience to doing it even involuntarily in the digester itself. Floating layer, it's already something which is the differentiation between hydraulic and solid retention time. The other thing is how to connect process design to trace elements, to enzymes, to biological knowledge. So macronutrients and trace elements, they are playing a fundamental role in the anaerobic digestion. Really common is and really easy to detect is the ammonia inhibition, so an excess of macronutrients. Maybe not a lot of people is knowing in the anaerobic digestion that even phosphorus plays an important role for the lack of this. So there are a lot of plants here in Italy using it as extra dosing. Then digesting very well the carbon, the fibrous, it means it brings us to a better CN ratio. So this gives us a strong hand to improve the efficiency at all. A lot of people is using trace element, but I'm talking especially about every time bioavailable trace elements based on chelates. What's this? It gives us biological stability, best efficiency. What it means, the connection is to the process design. If I know the biological understandings, the ongoings, then I can reduce the volume. I can use the same volume with a higher output. So what's the main issue? Process design has to be done by biological experts. Yes, there is a very strong component from engineering side, but the microbial knowledge is essential. We had here in Italy one example, more examples that we can reduce the feeding cycles from once till once a day, from 24 times a day. So different feeding system can be planned in a different way. With trace element, you have less foaming events. You can reduce the foam even together with the enzymes, and of course, even the floating layer. If you don't have the right trace elements and enzymes itself, or bacteria, then it's a little bit difficult. 2 or 3 numbers about trace elements. During biological startup, we have a really high need of trace elements, 10 times higher. If you have changing inputs from time to time, then you have to increase the trace element dosage. Enzymes itself, together with trace elements, increase the number of bacteria. Increasing the number of bacteria means you have to add more trace element. So with trace element and enzymes, you can use less and even cheaper input. What's the final goal? So process design, we could talk about hours and hours, but just to try to put together, I'm believing nowadays we are building too high to volume. So in the future, with a hydraulic retention time of 20 days, we should be able to digest nearly everything of input material, and with good biological knowledge and improvements, produce 70–80% of methane content. Why is this important? We are producing with biogas CO2. CO2, it's a problem, so we have to focus on new technologies to produce renewable synthetic biofuels. We need carbon negative technology, and anaerobic digestion must go towards this direction. Not immediately, it will be easy to do it immediately, but in between 5 years. But on the other side, from my point as agronomist, and never ever forget the needs of your main players, your microorganisms. So thank you for your attention.
Yeah, thank you, Stocker, and it was really interesting. And thank you once again for showing the importance of the process engineering. And yes, the statement we love very clearly that with addition of enzymes, the efficiency of the biogas plant can be enhanced. Thank you. And I would like to ask one question to Dr. Jain. Dr. Jain?
Yeah.
Yeah, we love your presentation. And when it comes to logo, every business is eager to market their own brand. And what benefits lie in the company integrating a general biogas logo in their communication, as well as we Indians are very cost sensitive. So one of the most important question from our side would be, what is the cost for adding this biogas logo?
Yeah, I think that if you look at websites and things about biogas, I think it is almost exclusively material that is business to business, and there has been no ambition to popularize this. So I think there's a lot of business to business communication, and which is of course excellent. But the problem is that when we reach to a point where we need to reach policymakers and to make it kind of fashion to be sustainable with biogas, then we have a lot to gain from also using kind of the tricks of business to customer communication. So even I think like a tech company. I think there's could be an advantage to use a logo, because then you suddenly you are visible to the large stakeholders selling the biogas to the customer, because then they realize, you're a biogas company, you're selling biogas technology. And I think also in this case, at least in Europe now, it's very much a question of, if the policies don't turn out right, even the largest producers in the world based in Italy will suffer from that. So I think there's definitely a large common gain in introducing the biogas lesson aside the company, promotion of the company. When it comes to cost and conditions, I mean, we're a non-profit organization, and I do this because I think it needs to be done to safeguard a swift transition to sustainable energy production and clever waste recycling globally. So I'm sure with your help, we could come to a practical solution for any company or stakeholder in India wanting to be part of this communication. Most companies, until now, most companies in Sweden that are using it are not paying anything. So this is not about making money for Biogas Academy. This is about helping the people and the companies that are doing the right thing. So if there would be a fee, it will be a completely nominal fee. So
okay, thank you. And Florian, I just wanted to understand one factor from your presentation, that your company is mostly recommending or using long shaft agitators which have been marketed or sold in India, and not the submersible one. And what are the benefits of using these long shaft agitators when we compare these with the submersible agitators?
Yes, we say we know it in Germany. We have normally in south of Germany thermophile biogas plants with more than 45 degrees temperature, and we know that in these tanks the submersible mixer have problems with the heating, with the temperature. The most time they go damaged. Because of this, we use normally our long shaft mixers, because you have the complete electrician and gearbox and everything outside of the tank, can make easier service on the mixer. Normally, you don't need many service on the mixers. Submersible mixer, you must change the oil or something, then you must put it out or on. And with a long shaft mixer, it's really easy to make a gear oil changing or something. I know in India the most time you have mesophil, I think, but you have really hard substrate like rice straw or something, and we think with long shaft mixer and digester every time a little bit better for service or something, and with wear and tears and such of things. Thank you.
Yeah, perfect. And in combination with Stalker, as I said that, when we talk about enzymes, then yes, in combination with enzymes, the agitators work well, because obviously the load consumption or the electrical consumption load will be reduced much. So I have one question for Stocker, that how important are these enzymes for biogas digester, and what are the most common mistakes which people make approaching new project? So can you please yes, Stocker.
Yes, enzymes and especially linked to trace elements. For me, adding enzymes, it means every time adding even trace elements, the number of bacteria which would have more food will be increased. A higher number, it means you need more available trace element. So with enzymes, we can reduce foaming events, we can reduce the viscosity, we can reduce the floating layer. All this leads to a reduced self-consumption. So this is important. But nowadays, very often enzymes are used when you have some problems, when you have already floating layers, and then maybe the seeing floating layers are disappearing, but they later on, they are not going on to use continuously enzymes. So with process design, we have to bring these experiences together to a new project. We know on the long run, you will have a lot of difficult digestible input materials, rice straw, you heard already it. So from there, I have to fix on mats. So if you have already a lot of water, liquid manure available, then a wet digestion will be possible. But I have seen here in Italy biomethane projects, 150,000 tons of input, 50,000 tons of fresh water. Water is too precious to do dilution in biogas plants. So process design has to be something looking forward, learning from the past, learning even from, there are examples of very really nice plug flows, but it's not, it has not become common to use them in an appropriate way. And let's say, if I have rice straw, if I have body straw, if I have corn stalks and so on, even if I do it on the wet digester, now or later I have to divide the solids from the liquids. So process design has to go a little bit more on. We can see it easily. I have experienced here with my customers in the States. They were saying, "Oh, sorry that we met you so late. We already built the second digesters. If you would have been, if it would be possible to meet before, so we could have avoided a lot of things." Deposits inside, and maybe from Armatech we can a little bit discuss more. I have developed a pattern to detect the deposit inside. So the number of mixers, the mixer itself, if it's high quality, if it's a lot of money. So you're trying to avoid to install one more. So we have to focus on already existing biogas plants, looking what are the problems. And if you have rice straw with 80% of dry matter, if you will bring it to a wet digestion, you need to dilute a lot, and dilution costs a lot of money. So this is process design is really, really important.
Yeah, perfect. And when you're talking about mixers and agitators, yes, Florin, does the propeller diameter has any influence in the selection of the mixers?
I think a slow-moving mixer have normally a bigger propeller up to 2.5 meters. We have our propellers with 1 meter 40 or 1 meter 60 diameter. I think when you have a really high dry matter content, you use normally a slow-moving mixer with a bigger propeller with a low RPM. From a paddle mixer have 10 RPM, or central mixer have 10 RPM or less. A submersible mixer, slow moving, or long air shaft mixer have approximately 70 up to 140 RPM. This is a slow moving mixer. And when you have really high dry matter contents or long fibers or something, I will prefer every time a slow moving mixer. When you have only cow dung or something, liquid manure, then you can use a fast mover. It's like water. When you have water, you can use it with a fast RPM, and then it's easier to mix.
Yeah, and I think we are about to close the session. And one last question to Stocker: that what is your outlook to the future of biogas in India or in general?
My outlook is, my wish is, we will and we must focus to deal with the CO2 which we are producing out from biomethane or behind the CHP. And the other thing is hydrogen, green hydrogen. One of the easiest and most simple ways would be produce it directly from biogas, from biomethane. This would be very important. So once we have an excess of CO2, once we have green hydrogen, let's say it will be easy. It's easy technically to produce synthetic renewable fuels. So the hype all for e-cars, it's nice. But if you look how many cars, 1 more billion cars all over the world, it takes 50 years, 100 years to convert them all to electrical cars. So then in the aviation, you go on the long distance flight, there couldn't be any alternative than immediately to use renewable fuels. So nowadays, we're using sometimes the heat. Here in Italy, normally never we use the heat. We produce electricity and we have CO2. And CO2 gives, for the climate change, gives a lot of trouble. We have to go over. For India especially, I hope you focus very well on quality, on process design, on biological experience, and that you're not repeating, please don't repeat the errors which we have imported from Germany, which German biogas plant has. And I, from time to time, doing this, and then I will close. So nowadays, you go to buy a car, and do you remember your car 15 years ago? There's a very, very high difference, very big difference. If you go to buy nowadays a biogas plant, and 15 years ago, it looks very similar. So I hope in India you can develop something which will be ahead of our European technology.
Sure, sure. And thank you, Stocker. And just to close the session, one last, the dream, one of my dreams will become reality when I'm able to fill my own gas-powered vehicle in a village where one of my customers farm, and more important is money stays with the farmer. So this is the dream I have, and let's work towards it. And thank you, everyone. And I would like to hand over to Amit.
Thank you so much for a very interesting session with visual presentations, sharing various technologies which could deal better through bio. Looking forward for that reality, Srinivas.
Yeah.
A big thanks to all our panelists, Mr. Florian Vuik, Mr. John Rapp, Mr. Agronomist Gunther Stocker. Thank you so much. And of course, to Mr. Srinivas Kasula, the moderator, who's a big supporter of REI. Ladies and gentlemen, with this, we come to the close of the knowledge sessions at REI Expo 3.0. Trust you quench your thirst of knowledge as we gain from the multi-sessions and high-end deliberations from our guests in these 2 days. Please join us at REI from 15th to 17th September, whereby we have multi-pavilions. To name a few, a pavilion by Indian Biogas, pavilion by UK, with multi-brands, along with multi-brands which would also be showcasing their products, technologies, and services. Connect for business associations and connect at multi-knowledge sessions. To conclude, we have the expo still open till 7 p.m. Please visit the floor and visit the booths on the Live E forum as we speak. Thank you once again. I'm Amit, and I look forward to see you soon. Thank you soon. Thank you again.
Thank you. Thank you, Amit.
Thank you.
Thanks, Shri.
Thank you, everyone.
Namaste.